In this section, we will talk about explicit versus implicit equations. Explicit equations are those that are solved for y. For example, y equals 3x squared minus 4x plus 7. The variable y is written explicitly as a function of x. Implicit equations are those that are not solved for y. And as a result, we must use implicit differentiation. When differentiating implicitly, we take d dx, derivative with respect to x, or sometimes we take the derivative with respect to time, but we take the derivative with respect to something of each side. It's usually x. Sometimes implicit differentiation is easier when solving for y proves to be difficult. To find dy dx, or the derivative of an implicit equation, we must realize that we are taking the derivative with respect to x. As a result, if the term involves y, we must apply the chain rule because we assume that y is defined implicitly as a differentiable function of x. And that sounds complicated. I'll simplify it a little bit later on. In other words, anytime an expression involving y is differentiated, dy dx will be a factor in the result. After differentiating, we isolate all terms of dy dx on one side, we factor out the dy dx, and solve for dy dx. Now, if none of this makes sense to you, don't worry about it. It will once we start doing some examples. Okay, example 1. Find dy dx. Find the derivative of y with respect to x. So here's the main thing to remember. We are going to be taking d dx of each term. Now, if you take d dx of x, imagine that you're just adding an x to the numerator, so this becomes 1. If you take d dx of a term involving y, then you add a y to the numerator, and you're left with a dy dx. This doesn't equal to 1, so we're going to have a dy dx left over in our answer. So for example, we got 2x to the third power minus 3y to the third power equals to 5. And when we differentiate, we take the derivative with respect to x, so d dx of each term. So we have d dx of 2x cubed, we have d dx of 3y cubed, and we have d dx of 5. Derivative with respect to x. Okay, now let's keep going with this. So here we just use our normal rules of differentiating. 3 times 2 is 6. This gives us 6x squared. And then we got to figure out what happens with this, with the d dx term. So imagine we are adding an x to it. dx over dx is 1, so there's nothing left over. Then we have 3 times 3, which gives you a 9y to the second power. Now what happens here, imagine we're adding this variable is a y, so imagine we're adding a y to the numerator. So the dy dx is going to remain. The derivative of any constant is equal to 0, so that's going to equal to 0. Once we differentiate, we isolate all terms of dy dx on one side, we factor out the dy dx and solve for dy dx. Our objective is to find dy dx. So all the terms of dy dx, there's only one in this case, it's on the left side, so we need to isolate this term, which means we move the 6x squared to the right. When we do that, we get negative dy dx 9y squared equals to negative 6x squared. Now we want to get the dy dx by itself, so first we divide by negative, and then we divide by 9y squared. So the negative divided by negative is 1, positive, 9y squared is 1. So we get dy dx equals to, negative divided by negative is positive, 6 and 9, these are going to reduce to be 2/3, and then we have x squared on the numerator and y squared on the denominator. So that is a derivative of the implicit function of y with respect to x. Let's take another example. We got radical x plus radical y equals 11, and y of 9 is 64, so we want to find y prime of 9. Okay, we'll deal with this part later. For now, let's just find the derivative, dy dx, derivative of y with respect to x. So first I'm going to write this as x to the 1/2 plus y to the 1/2 equals to 11. And then I'm going to take ddx of x to the 1/2 plus ddx of y to the 1/2, and that equals to ddx of 11. Okay, let's keep going. If I differentiate this, the 1/2 comes to the front, and I get x to the negative 1/2. What happens here? Put an imaginary x, dx. There's nothing left over for the first expression. Second one, we have ddx of y to the 1/2. So 1/2 comes to the front. So we're going to get plus 1/2 y to the negative 1/2. And then if I add a y here, this term does not cancel. So we're left with dy dx times 1/2 y to the negative 1/2. And the derivative of any constant is 0. Let's simplify this a little bit. This is going to be 1 over, let me go to the other side actually. So this is going to be 1 over 2 times the square root of x. Negative exponent moves to the denominator. Then we got dy dx. We have 1 over 2 times square root of y, and that equals to 0. We want to get all terms of dy dx on one side, which we have. So now we move the 1 over 2 radical x to the other side. So we get dy dx times 1 over 2 radical y. That's equal to 1 over 2 radical x. Now normally we would divide by this term to get the dy dx by itself, but we can't divide by a fraction. So instead, we're going to multiply by the reciprocal of the fraction, which is going to be 2 radical y over 1. Multiply by the reciprocal, that's 2 radical y over 1. So this is going to cancel out, and our objective is to get dy dx by itself, which we have now accomplished. We got derivative of y with respect to x. Over here, the 2 and the 2, they're going to cross cancel, so we're left with just radical y over radical x as the answer. And I made a mistake, sorry. When you move this over to the right, this should have been a negative. Okay, so we move this to the right, so this should have been a negative on both sides. So this should have been a negative 1 over 2 radical x, which would have made this whole thing a negative radical y over radical x. Okay, sorry about that. All right, now part 2. Once we get the derivative with respect to x, here's the next part. Here's what we know. We know that y of 9 equals to 64. So that means our x value is 9 and our y value is 64. So since we want to find y prime of 9, let's plug in x equals 9. But when we do that, we also have to plug in y equals 64. So y prime of 9, it means we're plugging in x equals 9 into the derivative. Y prime is the derivative, which is why we plug it into the derivative, not to the original equation. So we know that our x value is 9 and our corresponding y value is 64. So we're going to get this equals to negative radical 64 over 9. So y prime of 9 is equal to negative 8 over 3. Okay, next question, our next example. Use implicit differentiation to find dy dx. So we have y squared plus 8x cubed equals to 6y minus 5x squared. Now the first thing that I think is helpful is to get all the y's on one side and all the x's on the other side. So what I'm going to do is I'm going to take y squared, move the 6y to the left, which gives me a negative 6y, and then I take the negative 8x to the right. This gives me negative 8x to the third minus 5x squared. And then once I have all the y's on one side, all the x's on the other side, now I can take the derivative with respect to x of each term. I should move this over. So this is negative 6y. We take the derivative with respect to x of each term. All right. Now let's differentiate this. The 2 comes to the front. We got 2y, but remember, every time you differentiate, you put whatever variable is, you put it on the ddx. So this is going to be dy dx. That does not cancel, so we leave it there. The derivative of 6y is just going to be 6. And again, you put a y here, so it's going to be dy dx times 6. This equals to derivative of negative 8x cubed, so 3 times negative 8, that's negative 24x squared. Dx over dx, that's going to cancel. 5 times 2 is 10x, so it's going to be 10x. Once again, dx over dx cancels. So this is what we're left with. Our objective is to find dy dx. So now that the dy dx, we have all terms of dy dx on one side, we can factor that out. Factor out the dy dx. So you're left with 2y minus 6, and this equals to negative 24x squared minus 10x. Then we need to divide everything by 2y minus 6. So we divide by 2y minus 6, divide by 2y minus 6. So dy dx, derivative of y with respect to x, is equal to the numerator is negative 24 x to the second power minus 10x, all of that divided by 2y minus 6. Okay? Next example. This time we don't just want to differentiate, we want to find the slope of the tangent line to this curve. So first thing I'm going to do is I'm going to get all the y's on one side and all the x's on the other side. That's going to be kind of difficult in this case because this y is attached to the x, but let me do whatever I can. So I'm going to move the negative 3x squared to the right. So I have xy plus 2y cubed equals to 3x squared plus 15. Now I can't separate the x and y, so I have to kind of leave it like this. Okay, then I have to take the derivative of each term. So we have ddx of xy plus ddx of 2y cubed equals to ddx of 3x squared plus ddx of 15. Now when I differentiate this, notice what's happening. It's x times y. So we have a product, which means when we differentiate, we have to use the product rule, which says the following. If I differentiate two terms, ddx of ab, then I take ddx of a times b plus ddx of b times a. So differentiate the first term, multiply it by b, differentiate the second term, multiply it by a. So in our case, if I differentiate the first term, ddx of x is just going to be 1, and I multiply it by y. Then I'm going to add it to, if I differentiate the y, the derivative of y is just going to be 1, but I have left a dy dx because when I differentiate the y, there's a y that's going to be attached to it. So this gives you 1 times y, derivative of x is 1 times y, plus derivative of y is 1, but then we have dy dx, and we still have to multiply it by the first term, which is an x. So this all comes from the product rule of this. Now ddx of 2y cubed, you multiply 3 times 2, this gives you 6y to the second power. I add a y here, so that's going to be times dy dx. On the right side, 2 times 3 is going to be 6x. Dx, that cancels out. And the derivative of a constant is going to be 0, so we're not going to worry about that. So this is what we have so far. Now, if I want to solve for dy dx, I need to get all the dy dx's on one side and move everything else to the right. Okay, so this term has a dy dx, and this term has a dy dx. So the 1y, or 1 times y, which is y, this needs to move to the right. So 1 times y, this thing is y, I'm going to move it to the right. So I'm going to simplify this a little bit. 1 times x is x, so I get x times dy dx plus 6y squared times dy dx equals to 6x minus y. Then I have to factor out the dy dx. So I'll factor out the dy dx, and I'm left with x plus 6y squared, and this equals to 6x minus y. Divide both sides by the x plus 6y squared, and I get the following. 6x minus y over x plus 6y squared. That's a derivative. The next part, the tangent line, we will do this part in class.